This video is over section 2.5, solving limits algebraically. And in this video, we're going to go through an example of a function that has complex algebraic expressions. Okay, so this is number 9 in your book. It gives us a limit as x approaches 5 of that function. All right, first step whenever we see these types of problems is to try direct substitution. So for direct substitution, I plug in a 5 wherever I see an x. And on the top, when I plug in 5, I'm going to end up getting 0. And on the bottom, when I plug in 5, I get 25 minus 25. Also gives me 0. Okay, 0 over 0. When you see this, you think indeterminate form, not a valid answer. That means that we need to do more work. And what kind of work do we need to do? Well, we're going to try to simplify our function so that hopefully something will cancel out. We can try direct substitution again into our simplified function and hopefully get a valid answer. Okay, so let's try to simplify this function. So like we said, this function has complex algebraic expressions in it. And if you watch that video on the roadmap of how to solve these limit problems, whenever we solve a problem with complex algebraic expressions, we want to think factor. So let's factor both the top and the bottom. All right, our top here is a quadratic. The way we factor quadratics is we just factor them down into two binomials being multiplied by each other. This factors down into 2x plus 1 and x minus 5. And on the bottom here, we don't have a quadratic, but we have something called the difference of perfect squares. If you forgot what that pattern was, I wrote it down here for you. If you have two perfect squares being subtracted from each other, that just factors down into their square roots being added and subtracted. So this comes down into x plus 5 and x minus 5. Follows this pattern here. All right, so I factored both my top and my bottom. Now I look to see if anything cancels, which conveniently it does. Okay, after I cross out my common factors, now I'm just left with 2x plus 1 over x plus 5. All right, now I'm going to try direct substitution again, see what happens. When I plug in 5 into the top here, I get 2 times 5 plus 1, 10 plus 1, that gives me 11. Over on the bottom, 5 plus 5 gives me 10. This is a valid answer. That means I'm done with this problem. That means that the answer to this question is the limit as x approaches 5 of f of x is equal to 11 over 10. And that's it. Okay, so if you saw this problem and you're confused where to start, you might want to look at the video that had a roadmap of limit problems and how to approach the problems and the first step that you should do for a bunch of different types of functions you might see. If you started this problem, knew where to start, but you weren't sure how to go on from there, you might want to review a video over basic algebra rules that you might have forgotten because of a couple years ago. Or you can also look online for a lot of great resources. All right, that's it for this problem. I hope that was helpful.